What if the universe never grows angry, it only answers with silence, and that silence is drawing near? For thousands of years we have sent Cassini, Voyager and Juno into the dark, believing that data alone could unlock the universe. Yet every image, every signal that returned to us felt less like an answer, and more like a warning written in the language of gas magnetism and light. You have reached the edge of what knowledge can explain. Perhaps in that deepening quiet, the giants of our solar system, Jupiter, Saturn, Uranus and Neptune, are whispering truths that humanity has not yet learned to hear. Saturn trembles like a heart compressed beneath layers of cloud. Jupiter growls, a reminder of power beyond control. Uranus tilts as if wounded. Neptune burns faintly within its frozen shell, all of them challenging the laws we once believed were absolute. And amid the numbers, the theories and the faint radio echoes across space, a question begins to rise. Do we truly understand the universe, or are we awakening something that has always slept within it, and within ourselves? In this journey, we will travel through the gas giants to uncover the mysteries that even now science itself struggles to explain. It began with a whisper between worlds, a precise alignment written not in myth, but in mathematics. The year was 1997, and Cassini stood waiting on the launch pad, its golden skin gleaming beneath the morning sun. Behind it stretched the weight of 4 centuries of curiosity, the unspoken question humanity had carried since Galileo's trembling hands first turned towards Saturn's light. What lies within those rings? Cassini's journey would not be a straight path. It would dance through the solar system, weaving between giants, 2 slingshots around Venus, a third around Earth, and a final tremendous swing past Jupiter. Each encounter wasn't merely a maneuver of mechanics, it was a conversation between gravities, a celestial choreography calculated to perfection. That alignment, that fleeting doorway of opportunity opens only once every 6 centuries. Miss it, and the dream of Saturn would wait another lifetime. Imagine it a machine no larger than a school bus sailing through the silent ocean of space for 7 billion kilometers. Every trajectory, every fraction of an angle had to be flawless, for Cassini carried something irreplaceable. Inside, a fragment of Earth's will and 33 kilograms of radioactive plutonium to keep it alive. That energy, both gift and danger, glowed at the heart of its core. If a single calculation had faltered during its return past Earth, the sky could have turned deadly. Yet it did not. Humanity's faith in precision prevailed, and the probe sailed on, accelerating toward the cold brilliance of Saturn. As Cassini drifted farther from home, it became less a machine and more a messenger. Its sensors, like senses awakening in the dark, began to taste the sunlight growing weaker, the temperature dropping into silence. Around it, the stars no longer looked like points of light. They were windows into history, reminders of how far human hands had reached. Somewhere between the orbits of Mars and Jupiter, the spacecraft crossed an invisible threshold, the point where Earth's pull ended and the sun's whisper became the only sound left. In that silence, Cassini carried not just instruments, but a promise that even across billions of kilometers, curiosity would always find a way to move forward. When Cassini reached the end of its long journey, it was no longer just a probe, it was an elder among machines. After 13 years circling Saturn, it had mapped storms that stretched for thousands of kilometers, traced magnetic fields that pulsed like a heartbeat, and sent home images so hauntingly beautiful that they made the vast seem intimate. Yet like all things that burn too brightly, its time was running out. Fuel, that quiet breath of every spacecraft, was dwindling. Without it, Cassini would lose control, drift aimlessly, and risk colliding with one of Saturn's moons. And among those moons were worlds of possibility, Titan cloaked in haze, and Enceladus exhaling plumes of water that hinted at a hidden ocean. To crash upon their surfaces would mean contamination, a human fingerprint upon untouched biology. NASA made a decision that was both scientific and poetic. Cassini would not fade in silence. It would fall deliberately bravely into the world it had devoted its life to studying. This final descent was called the Grand Finale. From November 2016 onward, Cassini began a series of daring orbits, 22 loops threading the narrow space between Saturn and its innermost rings. It was a place no spacecraft had ever gone, a region filled with debris, radiation and uncertainty. The risks were immense. A single grain of ice travelling at cosmic speed could shred the probe apart. But Cassini flew anyway, cutting through that void like a diver plunging into an uncharted sea. Each pass brought new revelations. The rings once thought empty shimmered with tiny moonlets sculpting ripples like frozen music. Cassini watched the shepherd moons, Atlas Pan-Daphnis, sweeping through the dust, their gravity-shaping waves that looked almost alive. One image in particular, the spiral density wave of Janus and Epimetheus, seemed to encode time itself, each crest a record of their orbital dance like growth rings in the trunk of a cosmic tree. By the 22nd orbit, Cassini's path was set. Its final dive would carry it beneath the rings, skimming just above the clouds, where the atmosphere thickened into golden fire. On September 15, 2017, the spacecraft turned its antenna toward Earth one last time. As it entered the haze, thrusters fought to keep its gaze steady. For 73 seconds, data flowed pressure, temperature, magnetic readings, each packet a heartbeat. Then the resistance grew. The heat rose. The antennas began to tremble. At 900 kilometers above the clouds, the signal wavered. 10 seconds later, it vanished. Back on Earth, the data arrived with a delay, an echo traveling across 1.4 billion kilometers. Cassini was gone, yet its voice still spoke, carried by light itself. In the quiet control room, no one applauded. There was only a silence heavy sacred, and the awareness that for one brief moment humanity had touched the edge of the impossible. At the edge of dawn over Saturn's cloud tops, Cassini began its final breath. The probe had already threaded the rings 22 times, danced with moonlets, and touched the borders of the unknown. Now it was time to descend, not as an ending, but as an experiment written in fire. As Cassini approached the upper layers of Saturn's atmosphere, the spacecraft was travelling at nearly 123,000 kilometers per hour, fast enough to cross the Pacific Ocean in less than 3 minutes. This was not a crash. It was a controlled entry, a planned sacrifice. Its instruments were still alive, still whispering data through the void readings of hydrogen density, ion distribution-charged particles, and minute traces of methane. The first brush of the atmosphere was like a ghostly hand, gentle at first, then tightening. The air rich in hydrogen and helium began to bite at Cassini's golden surface. Friction grew, and with it came heat, glowing plasma streaming across its antennas like ribbons of light. Inside the spacecraft, the computer fought to maintain stability. Tiny thrusters, fueled by the last drops of propellant, fired in short bursts, correcting spin, keeping the high-gain antenna locked on Earth. Through that narrow beam, Cassini sent everything it could, every last fragment of truth before the storm consumed it. Scientists had one request to the probe before it fell: keep sending no matter what happens, and Cassini obeyed. For 73 seconds, it recorded direct measurements no spacecraft had ever made before. The atmosphere thickened, ion levels spiked, magnetic readings fluctuated wildly, hints perhaps of currents deeper within Saturn, unseen by any telescope. Cassini was flying blind now, the pressure around it climbing hundreds of times higher than that of Earth's sky. Then the thrusters reached their limit. They fired at full strength, fighting the inevitable until they simply couldn't. In that instant, the spacecraft began to tumble. The radio signal, once a steady heartbeat, flickered, then faded into static. Back on Earth 1.5 hours later, the signal arrived, the final ghost of Cassini. There was no image, no sound, just data, temperature spikes, plasma flow, magnetic irregularities. The last line of code ended mid-transmission abruptly, like a sentence without a period. It was over, or perhaps it had just begun. Because even as the spacecraft disintegrated in the mustard-coloured clouds, its final measurements raised more questions than answers. Why did Saturn's magnetic field remain so perfectly aligned, a condition physics said should be impossible? What caused those sudden pockets of ionization and bursts of heat near the terminator line? Was there something beneath the clouds, a hidden mechanism that twisted energy in ways we did not yet understand? The data from the plunge revealed small oscillations in density as though the atmosphere itself pulsed. Some researchers proposed that these were gravity waves, ripples of motion travelling from deep within the planet, carrying echoes of Saturn's interior rotation. Others suspected electrical storms powerful enough to warp local magnetic readings. None of it was certain. Cassini's death, it seemed, had given birth to a new mystery. As the last fragments of the probe burned to ash, its atoms joined the atmosphere it had studied so long. And in that act, the merging of machine and planet Saturn absorbed the messenger it had inspired. The world remained silent as it always had been, yet its silence felt different now. Not empty, but full of the questions Cassini left behind, and of a quiet promise that someday humanity would return not to conquer the unknown, but to listen to it once more. When the fire of Cassini faded into the clouds, one truth remained. Saturn itself was no longer a solved puzzle, it was a contradiction. Every image, every reading, every echo Cassini sent home hinted that the planet might not obey the rules we thought were immutable. It was as if behind those graceful rings, nature had hidden an equation that refused to balance. For decades, scientists had tried to answer a deceptively simple question. How long is a day on Saturn? On Earth we count by the sun's movement. On Jupiter, by the rotation of visible storms. But Saturn offers no such clarity. Its clouds, whipped by winds of 800 kilometers per hour, drift at different speeds depending on altitude. No solid surface, no landmark, nothing to track. Cassini's instruments turned instead to magnetism. A planet's magnetic field usually wobbles as it spins, revealing its internal rhythm. But not Saturn's. Its magnetic pole was nearly perfect, aligned with its axis of rotation to within 1/10 of a degree. By all known physics, that should be impossible. A planet's dynamo, the molten metallic heart that spins to generate magnetism, cannot remain aligned so precisely. If it did, the field should collapse. Yet Saturn's endured steady and strong, 580 times more powerful than Earth's. It was as though something deep within the gas giant was rewriting the rules of electromagnetism. Some researchers suggested a second dynamo, an upper layer of metallic hydrogen rotating at a different speed, warping the lines of the magnetic field until they appeared perfectly straight. Others imagined electrical winds flowing through conductive clouds, creating a false symmetry that hid the true core beneath. And the mysteries did not end there. Saturn glowed with more heat than it received, nearly twice the energy expected. Some blamed residual heat from its formation slowly leaking through the centuries. Others proposed a far stranger cause: diamond rain. Under the immense pressures of its deep atmosphere, methane may split into carbon, which then crystallizes and falls, friction igniting the lower layers. Each storm of diamonds would create bursts of heat, Saturn's silent furnace glittering in the dark. Then there were the auroras. Unlike Earth's, they did not always dance to the rhythm of the solar wind. Sometimes they appeared when the sun was calm, blooming at the poles in silent defiance. Perhaps they were born not from outside, but within the magnetic sigh of Saturn itself, breathing out energy gathered from its rings and moons. Each answer led only to another question. The data from Cassini, precise and abundant, seemed to reveal less certainty the more it was studied. Saturn, it appeared, was both lawful and lawless, a paradox bound in hydrogen and light. If the planet could defy the expectations of physics, perhaps the problem was not Saturn at all. Perhaps it was us still too young, too certain to see that in the orchestra of the cosmos, even the laws of nature may sometimes improvise their own song. Beyond the golden halo of Saturn lies another world, one that doesn't whisper like its ringed sibling, but commands with thunder: Jupiter. To look upon it through the lens of science is to stare directly at gravity's masterpiece, a world so immense it bends not just space but the very rhythm of the solar system around it. It is the largest planet we know, 11 times the diameter of Earth and over 300 times its mass. But size alone is not what defines its dominion. It is weight, the sheer gravitational authority of its being. Jupiter's pull is so vast that it holds more than 2/3 of all planetary mass in the solar system. And in a quiet, elegant irony, that mass is enough to tug even at the sun itself. We often imagine the planets tracing neat circles around the sun, a stable ballet choreographed by physics. But in truth, the dance is shared. The sun and Jupiter orbit a common point, the barycenter, which because of Jupiter's might lies above the surface of the sun. It's a cosmic seesaw, where even our star must nod to the planet's gravity. Every 12 Earth years, that invisible fulcrum moves in space, pulling the sun into a gentle sway. From afar, one might almost think the sun wobbles, acknowledging Jupiter's quiet authority. This balance of forces may have shaped the solar system we inhabit. Many scientists believe Jupiter's gravitational field acted as both architect and destroyer, guiding early asteroids, scattering comets, and sweeping debris from the young sun's orbit. It may have saved Earth before Earth even began. Without Jupiter, the inner planets might never have formed in peace. The early solar system could have been a firing range of collisions, worlds shattering before they could ever cool. Yet gravity's generosity has a shadow. Jupiter's same force that shields the inner planets can also destabilize. Its resonance pulls subtly at Mercury's orbit, elongating it, twisting it over millennia. Astronomers have modelled futures where that resonance grows a slow chaos that might someday eject Mercury from the solar system entirely or send it spiralling into the Sun. Protection and peril creation and disruption. Jupiter embodies them all. It is both guardian and threat father and executioner. Around it, 67 moons whirl, each one a reminder that its gravity not only controls but nurtures. Even the Sun must bend ever so slightly in acknowledgement. If Saturn is a symphony of mystery, Jupiter is a proclamation, the loud, unyielding voice of physics made manifest. And yet, as we peer closer into its clouds, even that voice begins to tremble, whispering of forces and patterns that may not be as simple as we once thought. Because within its storms lies another story, one of colour chemistry and something that refuses to die. To understand Jupiter is to confront the storm that never sleeps. For more than 4 centuries, a single scar has marked its southern hemisphere, vast enough to swallow Earth whole, yet graceful as a whirl of crimson silk. Astronomers call it the Great Red Spot, though the name barely captures its scale or mystery. Through the lens of Cassini, Galileo, Juno, and 100 telescopes on Earth, the storm's face has changed colours, deepening from brick to amber, shrinking in size, pulsing with life like something breathing beneath the clouds. It has raged for at least 350 years, perhaps longer surviving while others faded away, and yet no one truly knows why. At its heart, the Great Red Spot is a hurricane, inverted a vortex so large that it defies our atmospheric logic. On Earth, hurricanes feed on heat and moisture born and killed within weeks. But on Jupiter there is no land, no sea, no friction to end the spinning. The storm draws energy from a deeper source, the planet's own warmth radiating upward, from an interior hotter than it should be. That heat stirs the hydrogen atmosphere like breath through fire, sustaining the vortex endlessly. Winds within the red spot race faster than 600 kilometers per hour. Layers of ammonia and sulfur crystals drift like ribbons through its crown, twisting in currents that spiral counterclockwise, a hemisphere's heartbeat painted in red. But the question that has haunted scientists since the first telescopic sketch in the 1600s is simple: why red under sunlight? Jupiter's clouds are white and gold, made of ammonia ice, yet in the spot the colour burns deep, almost organic, like rust or blood. Some propose that ultraviolet light from the sun strikes ammonia and acetylene high in the atmosphere, producing complex molecules, tholins, that stain the storm crimson. Others argue the colour comes from compounds dredged up from deeper, hotter layers, where chemicals change form under immense pressure. But the truth remains evasive. Laboratory experiments reproduce parts of the hue, never the whole. Perhaps the red spot's colour is a signature of chemistry we have never recreated, a dance between light and gas that exists only in Jupiter's pressure and cold. Or perhaps, as some speculate, it is the visible trace of electrical storms beneath the clouds, lightning and plasma forging new molecules in flashes unseen from above. Still, there is beauty in the uncertainty. The Great Red Spot is not chaos but persistence, a living emblem of balance between creation and decay. It has shrunk by nearly 1/3 in the past century, yet somehow grows deeper, richer, more intense, as if the planet itself refuses to let the storm die, as if Jupiter needs it the way a heart needs its rhythm. The Great Red Spot endures, spinning on a world without rest, a monument to motion itself. And somewhere inside that endless spiral perhaps lies a secret older than our science, the quiet truth that even storms can be immortal. Beyond Jupiter's swirling clouds lies an invisible empire, one not made of matter but of force. A domain where charged particles spiral through magnetic corridors, moving faster than bullets, trapped in loops of pure energy. This is Jupiter's magnetosphere, the largest structure in the solar system, a realm so vast that if it glowed, it would outshine the full moon in our night sky. The planet's magnetic field is 14 times stronger than Earth's, yet its reach is millions of times greater. It stretches outward like a shield, enveloping not only Jupiter but many of its moons, a magnetic bubble more than 7 million kilometers across, sweeping through space like an invisible tide. Here radiation reigns. Every second, high-energy electrons and protons slam into anything that enters spacecraft moon's dust. To approach Jupiter is to step into a storm of invisible fire. Even the mighty Galileo probe, built to survive the hellish descent into the planet's clouds, struggled against the onslaught. Electronics glitched, sensors failed. Memory corrupted not from impact or heat, but from information itself being torn apart by radiation. Juno decades later had to dance cautiously between these belts wrapped in titanium armor to keep its instruments alive. Yet amid this danger, something extraordinary happens. Life, or the conditions for it, may persist in defiance. Within Jupiter's magnetic kingdom orbit 4 great moons, the Galilean siblings Io, Europa, Ganymede and Callisto. Each one lives under constant bombardment. On Io, volcanoes erupt without pause, spewing sulfur and plasma that feed the very radiation belts that scour its surface. Europa, bathed in that same energy, hides an ocean beneath its ice, an ocean warmed not by sunlight, but by the ceaseless kneading of Jupiter's gravity and magnetic tides. The same radiation that sterilizes its crust might also provide the chemistry needed for life below. A paradox, death above possibility beneath. Ganymede, the largest moon, carries its own magnetic field, the only moon in the solar system to do so, locked in an intricate magnetic dance within Jupiter's greater field. Callisto, farthest and oldest, bears the scars of cosmic impacts, but remains in the outer calm, orbiting where radiation thins and silence returns. Together these worlds form a system within a system, miniature planets, orbiting their colossal sun, each sculpted by Jupiter's unseen hand. Some scientists believe Jupiter's magnetosphere acts as both shield and sculptor, a protector of the inner solar system from cosmic debris, yet also a gatekeeper, filtering what reaches beyond. Others wonder whether it hints at something deeper, a planetary dynamo so stable, so immense, that it challenges our models of how magnetic fields are born and maintained. To stand in Jupiter's shadow, if one could, would be to feel the hum of invisible lines of power stretching across millions of kilometers, singing in radio waves and particle bursts. It is a place where radiation shapes worlds, and where even silence vibrates with energy, proof that in the universe's grand design, power and danger are often the same thing. Far beyond the fiery storms of Jupiter drifts a world that turns on its side, a silent glacial planet, rolling through space like a sleeping giant. Uranus. Among all the planets of the solar system, none behaves quite like it. Its axis is not upright like Earth's, nor gracefully tilted like Saturn's. Instead, Uranus lies nearly flat, spinning as though it had fallen over its poles, facing the sun one by one for decades at a time. Astronomers call it an anomaly. But perhaps it is more than that. Perhaps it is the scar of an ancient catastrophe. The leading hypothesis is simple in concept, yet staggering in implication. Billions of years ago, during the chaotic youth of the solar system, a colossal impact occurred. A planet roughly the size of Earth, a rogue world drifting through the dust and debris of early formation, may have struck Uranus in a glancing, devastating blow. The collision would have been silent in the vacuum of space, but its violence beyond imagining. The impact tilted Uranus by 97 degrees, sending its axis sprawling. Its interior shattered its atmosphere, boiling into chaos before settling once more into stillness. Some simulations suggest the strike might have occurred twice, one initial impact followed by a secondary glancing blow that stabilized the new orientation. Others propose that a chain of smaller collisions spread over millions of years slowly pushed Uranus over like a spinning top, losing balance. Whatever the cause, the effect is permanent. The planet now rolls around the sun like a marble on its side, its poles taking turns facing the light. For 42 years, one hemisphere bathes in a continuous day, while the other sinks into a night that lasts just as long. When Voyager 2 flew past in 1986, the only spacecraft ever to visit it found a world eerily calm, pale blue and featureless, as though still frozen in shock from the trauma that shaped it. But even in stillness, the consequences of that ancient impact ripple outward. Uranus's magnetic field does not emerge neatly from its poles, but at a wild, off-centered angle, as though the core that generates it has been displaced, twisted within. Its moons orbit along the same tilted plane, locked forever into their parents' fallen geometry. And beneath the clouds, something strange may be hidden, a core fractured, not molten like Jupiter's or Saturn's, but layered with ice and silicate debris, the remnants of the intruder that changed it. If so, Uranus carries within its cold heart the memory of another world, a ghost embedded in ice. It is a reminder that even planets can bear scars, that creation in the cosmos often begins with destruction. And as Uranus rolls endlessly through the dark, it does not spin like a planet, should it turns like a survivor moving forever sideways through time. Beneath Uranus's pale blue serenity lies a world the eye cannot see, a world of unimaginable pressure, where matter itself begins to behave like music composed by physics. To most telescopes, Uranus is a simple sphere of gas and mist. But beneath those tranquil layers of methane and hydrogen hides a secret that challenges our imagination, an ocean not of water, but of ice that flows like liquid metal. Unlike Jupiter and Saturn, whose cores are forged from hydrogen compressed into metallic plasma, Uranus belongs to a different family, the ice giants. Most of its mass is not gaseous, but composed of water, ammonia and methane locked together under enormous pressure, forming a substance that is neither solid nor liquid, but something in between. Imagine a sea where ice behaves like molten glass sliding slowly under gravity, illuminated by faint electrical currents that shimmer like veins of light. This is Uranus's mantle, a slow-moving ocean of frozen storms stretching thousands of kilometers deep. And deep within that darkness, another phenomenon may unfold, one so poetic it sounds impossible: rain made of diamonds. Scientists believe that in the crushing depths of Uranus, temperatures soar to thousands of degrees, and pressure climbs millions of times higher than on Earth's surface. In those conditions, methane, the simple gas that gives Uranus its gentle blue hue, begins to break apart. The hydrogen escapes upward, but the carbon atoms, stripped bare and compressed, fuse into crystalline lattices. In that alien night, it rains diamonds millions of carats at a time, falling through the slushy layers, glittering briefly before melting into liquid carbon. Some may sink all the way to the core, forming a vast ocean of molten diamond surrounding the planet's heart. It sounds like fantasy, yet laboratory experiments on Earth have reproduced the beginnings of this process. Scientists using shockwave lasers have witnessed methane turning into nanodiamonds under similar pressures. What they cannot reproduce, however, is the sheer scale an entire planet where carbon snow becomes diamond rain. If true, this process could explain why Uranus radiates so little heat compared to Neptune. Perhaps those diamonds falling through the mantle release energy, slowly locking thermal motion deep inside, preventing the warmth from escaping. Or perhaps the internal structure of Uranus, fractured by its ancient tilt, allows heat to leak unevenly, creating regions of slumbering convection instead of the boiling turbulence seen on other giants. In either case, the diamond rain hypothesis is more than a dream. It is a window into chemistry reshaped by gravity. And so, Uranus becomes more than a frozen relic. It is a paradox, a planet of stillness concealing an ocean that moves like thought and storms that rain jewels into eternity. If one could listen beneath its clouds, perhaps the rain would sound like distant chimes, each drop a fragment of starlight falling toward a core that remembers the violence of its birth. Uranus does not only spin sideways, its very magnetism seems to have followed it into that fall. Where most planets align their magnetic poles roughly with their axis of rotation, Uranus bends the rule into something almost absurd. Its magnetic field is tilted nearly 59 degrees from its spin axis, and the centre of that field isn't even inside the planet's core, it's shifted thousands of kilometres away from the centre. In other words, the planet's magnetosphere seems to wobble in space, like a lantern swinging from an invisible string. This misalignment turns the simple rhythm of day and night into a strange cosmic ballet. As Uranus rolls around the Sun, its magnetic field twists and folds, opening and closing like the petals of a flower every time it faces solar wind. Radiation belts form and dissolve in waves. Charged particles spiral erratically, carving ghostly auroras that bloom, not just at the poles, but across unexpected latitudes, shimmering rings of turquoise light flashing where physics says they shouldn't exist. The cause of this chaos remains uncertain. Some scientists believe that the source of Uranus's magnetism doesn't lie deep within its metallic core, as it does for Earth or Jupiter, but within that middle layer, the slush ocean of water, ammonia and methane that conducts electricity under immense pressure. If the convective flows within this layer are lopsided or fragmented, they could twist magnetic fields off-center, creating the strange tumbling geometry we observe. Others suggest the planet's violent birth, that ancient collision that knocked it sideways, may have shattered its internal structure, displacing the dynamo and leaving it to generate magnetism from a tilted, broken geometry. But Uranus's oddities don't stop with its magnetosphere. Encircling the planet are 13 thin, dark rings discovered in 1977 and later imaged by Voyager 2. They are almost invisible, composed not of bright ice like Saturn's, but of carbon dark debris, each grain coated in soot. And here lies another puzzle. Those rings appear young, perhaps no older than 600 million years. In cosmic terms, that's yesterday. Why would an ancient world possess such youthful adornments? One possibility: the rings are the aftermath of destruction. A moon torn apart by gravitational stress or shattered by a collision could have left behind its remains ground into dust and rock that now encircle Uranus in narrow bands. Another idea is that they are transient, forming, fading and reforming across eons like scars that never quite heal. Every orbit, these rings tell a quiet story of instability. Moons like Cordelia and Ophelia act as shepherds, tugging the edges into shape, keeping the bands from dissolving into the void. Without them, Uranus's delicate rings would scatter into space within 1 million years, a blink in planetary time. So the planet rolls its magnetic field, tilting wildly, its rings circling like the fragments of an ancient memory. A world forever unbalanced, a reminder that in the universe even elegance can be born from asymmetry, and that perfection may sometimes wear the shape of ruin. Before any telescope ever glimpsed its sapphire hue, Neptune existed only as a number. It was discovered not by sight but by mathematics, a triumph of human logic over cosmic distance. In the early 1800s, astronomers noticed something strange. Uranus, newly found and carefully charted, was misbehaving. Its orbit drifted ever so slightly off course, as if tugged by an unseen hand. Newton's laws worked too well for coincidence. Something massive had to be out there disturbing its path. Two men working worlds apart, Urbain Le Verrier in France and John Couch Adams in England, began calculating the impossible. Using only quill ink and mathematics, they traced the tremors in Uranus's orbit backward, triangulating the position of a ghost planet that no one had yet seen. On a September night in 1846, Johann Galle turned his telescope toward the coordinates Le Verrier had sent in a letter. Within an hour, the invisible became visible. Neptune shimmered into existence exactly where the numbers had predicted a blue lantern, burning 30 times farther from the Sun than Earth. It was the first planet found by pure reasoning, an idea made real through geometry. But if its discovery was an ode to precision, the planet itself was not. Because once observed, Neptune began to betray the very logic that had revealed it. At 30 astronomical units, it receives less than 1,000th of the sunlight that warms Earth, a dim, icy wasteland one would expect. Yet Neptune radiates far more heat than it receives. In fact, it emits nearly 2.5 times the energy falling upon it from the Sun. Its sister planet Uranus, similar in size and composition, does not. It is eerily cold, nearly inert. Both worlds formed together share the same basic chemistry: water, ammonia, methane, and yet one burns with unseen fire while the other slumbers in near-frozen silence. This imbalance defies simple explanation. Some theories claim Neptune still carries primordial heat left from its formation, its interior slowly releasing ancient energy trapped for billions of years. Others propose convection currents, vast plumes of material rising and falling in slow motion, stirring the planet's depths and generating warmth. And then there is the more haunting idea that Neptune once experienced what Uranus did, a colossal impact, but instead of knocking it sideways, the collision compressed it, igniting deep layers and setting its core in motion. The energy of catastrophe transformed into the quiet, steady heat we observe today. That could explain the paradox: Uranus, the tilted survivor, lost its internal warmth. Neptune, the compressed twin, kept it. Two worlds born together, separated by fate, one scarred, one smouldering. Every time the Sun's faint light reaches Neptune, it meets a defiant glow, rising from within, as if the planet remembers an ancient wound and still burns from it. It is a reminder that not all light in the cosmos comes from stars. Sometimes it comes from what survives them. If Neptune's warmth is a paradox, then its atmosphere is a rebellion. Far from the Sun, where sunlight is but a dim whisper, one would expect calm, still skies, frozen silence, a planet asleep beneath its faint glow. Instead, Neptune roars. Its winds scream across the planet faster than any in the solar system, reaching 260 kilometers per hour, almost twice the speed of sound. How can such violence exist in such darkness? This is the question that haunts every image returned by Voyager 2, by Hubble, and by modern telescopes peering across the abyss. Theories abound, but none fully tame the mystery. Some say Neptune's ferocity is fueled by that internal heat, a slow-burning engine that churns its atmosphere from below. The heat rises through the methane clouds, colliding with the icy winds descending from the upper layers. The result is chaos, a never-ending storm system that circles the planet like an orchestra without a conductor. Others suggest that Neptune's winds are driven not by temperature at all, but by motion, that deep convection currents and pressure waves act as pistons, transferring momentum through the dense air, accelerating the winds far beyond what sunlight could ever achieve. It is a system so efficient that it defies thermodynamics. The colder the planet grows, the faster it seems to spin. In Neptune's skies, entropy appears to have surrendered. And then there is the Great Dark Spot. When Voyager 2 flew by in 1989, it captured a storm almost the twin of Jupiter's Great Red Spot, a vast elliptical void dark as ink and nearly the size of Earth. It swirled at the planet's equator, bordered by clouds of methane ice, with bright white streaks racing around its rim, supersonic jets forming and breaking like ocean surf. To scientists it was a revelation. Even at the frozen edge of the solar system, a world could host tempests of unimaginable scale. But when the Hubble Space Telescope looked again just a few years later, the Great Dark Spot was gone, vanished, dissolved without a trace, and then years after that another appeared smaller, fainter in a different hemisphere. Neptune, it seems, does not have one enduring storm, but a rhythm vortices that live die and are born anew, as if the planet itself breathes through them. No one yet knows why these storms form, or what triggers their disappearance. Perhaps they are born of deep thermal plumes rising from below the visible clouds. Perhaps magnetic anomalies twist the flow of gases, creating temporary whirlpools of shadow. Or perhaps in the distant silence where Neptune reigns, storms are simply part of its pulse manifestations of an atmosphere too restless to ever truly sleep. As we watch from afar, we see only the surface clouds of blue ice storms that come and go. But beneath them, something endures a ceaseless exchange of energy that should not exist yet does. The universe, it seems, has a fondness for breaking its own rules, and Neptune is where that fondness becomes a storm. If Neptune's winds defy reason, its magnetism mocks symmetry. Like Uranus, it carries a magnetic field that seems to have been sculpted by an invisible hand, tilted 47 degrees from its axis of rotation and displaced far from the planet's core. In other words, the magnetic centre of Neptune does not align with its heart. It floats as if detached adrift within the planet's shifting layers. Each rotation sends that lopsided field spinning through space, tracing a vast corkscrew-shaped path that whips through the solar wind. To an observer on one of its moons, the field lines would appear to twist and breathe, opening and closing, like the tide creating storms of radiation and streams of charged particles that spiral out in arcs of invisible fire. This strange geometry confounds the models that have served us for other planets. On Earth, iron churning in the liquid outer core drives the magnetic field. On Jupiter, metallic hydrogen conducts the same role. But on Neptune, the field seems to come from somewhere higher, perhaps not from a solid core at all, but from a conductive ocean buried deep within the mantle where exotic materials churn under impossible pressures. In that shadowed seawater, ammonia and methane are crushed into a plasma of ions. It is neither gas nor liquid, a dense opaque fluid that conducts electricity as easily as metal. Within that ocean, convective cells may twist and spiral, creating electrical loops that ignite Neptune's skewed magnetosphere. Each current born there might stretch for thousands of kilometers, curling through the mantle like lightning frozen in motion. And yet recent models suggest something even stranger. If methane breaks apart under such pressure, carbon atoms could form chains, sheets, or entire rivers of molten diamond, an ocean of carbon glowing faintly in the dark. Such a layer would not only alter Neptune's density and magnetic properties, but could act as a conductor, reshaping how the field emerges into space. The tilt we see might not be a flaw, but a side effect, the signature of a hidden world below where carbon flows like water and storms rage in silence. Even Neptune's auroras betray the irregularity of its field. Unlike Earth's northern and southern lights, which crown the poles in symmetry, Neptune's glow appears off-center, sometimes arching across mid-latitudes like crooked halos. These faint SR arcs, spectral aurora regions, flicker and fade unpredictably, responding not only to the solar wind but to internal surges of magnetic tension. It is as if the planet's interior breathes magnetic storms of its own, exhaling light from its fractured heart. We see Neptune as calm as serene a cold blue orb at the edge of the sun's reach. But beneath that tranquil face, every law of order seems bent redefined, a magnet askew. a sea of carbon lightning, a world both stable and unbalanced, proof that beauty in the cosmos often hides within the broken symmetry of its design. Encircling Neptune like whispers of forgotten matter are 5 faint rings, each one delicate, fragmented, and strangely incomplete. They do not stretch in smooth, perfect loops like Saturn's majestic belts. Instead, Neptune's rings appear torn, interrupted by luminous patches known as arcs, as if parts of the rings have refused to finish their orbit. These arcs gleam, faintly shimmering against the blackness, their presence both fragile and defiant. They should not exist, yet they do. By all the laws of orbital mechanics, such arcs should disperse. Particles in a ring constantly circling a planet spread evenly over time, smoothing themselves into uniform bands. But Neptune's arcs remain clustered like cosmic knots of resistance. For decades, astronomers have puzzled over this defiance. How do these bright segments, liberty, equality, fraternity, and courage, as they were poetically named, cling together while everything else drifts apart? One explanation lies in the gravitational choreography of Neptune's moons. Tiny satellites such as Galatea orbit near the Adam's ring, acting as cosmic shepherds. Their gravity resonates with the ring particles, creating pockets of stability, where matter accumulates arcs held in place by rhythm rather than by solidity. It is a celestial echo of music, each moon's orbit striking a note, each ring vibrating in harmony, producing intervals where time itself seems to pause. But others believe there may be more, that the arcs are scars of something ancient. Perhaps they are remnants of a moon torn apart long ago, its debris still clustering in the last stable orbits, fragments bound by memory rather than force. In this interpretation, Neptune's arcs are not living features, but funerary ones, the last breath of a shattered body caught forever in motion. That story finds its echo in Triton, Neptune's largest and strangest moon. Unlike every other major moon in the solar system, Triton does not follow the planet's spin. It moves backward, a retrograde orbit flowing against Neptune's rotation, like a salmon swimming upstream. This single fact betrays its origin. Triton was not born here. It was captured. Long ago, it may have been a wandering body, perhaps a dwarf planet, twin to Pluto that drifted too close to Neptune's gravity well. In a moment of celestial theft, Neptune seized it, pulling it into orbit. The capture would have unleashed chaos, older moons, torn apart collisions, scattering debris that may have become the planet's rings. The evidence of that violence lingers still, the dark arcs, the uneven ring system, the peculiar tilt of Triton's path. Today Triton is a frozen world, smooth plains of nitrogen ice, thin geysers venting gas into the void. But beneath that calm surface, tidal forces from Neptune's pull may keep a hidden ocean alive, warmed by friction and memory. It circles its captor slowly, its fate sealed. In perhaps 1 billion years, gravity will drag Triton closer, and it will shatter, creating a final glorious ring around Neptune before vanishing entirely. So the planet of winds holds its prisoners' rings that should not exist, a moon that should not belong. Together they form a portrait of quiet tension order, held together by ruin beauty born from capture. In Neptune's shadowed kingdom, even destruction has learned how to dance. At the heart of every gas giant lies a silent song, a vibration so deep it can only be heard in mathematics. Each world, Saturn, Jupiter, Uranus, Neptune, hums with pressure waves that travel through their dense interiors like sound through the body of a living cello. Cassini once detected these rhythms in Saturn's rings, ripples of gravity so precise they revealed the planet's heartbeat. 10 hours, 33 minutes and 38 seconds of silent rotation. It was as if Saturn itself played a note that reverberated through space. And perhaps Jupiter, Uranus and Neptune are part of the same orchestra. Imagine the solar system's outer realm not as a cold frontier, but as a slow-moving symphony, each planet vibrating to its own inner frequency, energy flowing from molten hearts, through oceans of metallic hydrogen, through mantles of liquid diamond. If sound could travel through vacuum, the music would be endless. Each of these worlds shares a secret, a transition layer where pressure turns gas to fluid, fluid to plasma, and plasma to crystal. There, the known laws of matter blur, electrons begin to swim free, molecules reshape themselves, and carbon, once invisible, becomes diamond. In Saturn and Jupiter, this process may create electrical storms, lightning flashing through metallic rain. In Uranus and Neptune, it may form vast fields of carbon collapsing into solid jewels before melting again in the depths. Could it be that these rains are not isolated phenomena, but the same planetary process expressed through different temperatures and pressures? Perhaps every gas giant is conducting an ancient experiment, nature's quiet attempt to test the boundaries of its own equations. We often think of planets as static spheres of stone and gas. But what if they are alive in a different sense, not biological, but resonant evolving systems shifting chemistry into new forms under gravity's slow hand? If so, then the music of Saturn's rings, Jupiter's storms, Uranus's tilt and Neptune's winds are all part of one cosmic composition, the universe listening to itself through matter. In the laboratories of Earth, scientists have begun to simulate the unthinkable. With shockwave lasers and supercompression chambers, they recreate the conditions of Uranus and Neptune, billions of pascals of pressure, thousands of degrees of heat. Under these forces, methane fractures, hydrogen atoms are torn away, and the remaining carbon forms fleeting diamonds shimmering for milliseconds before melting into glowing plasma. It is not myth, it is measurable. If this same process unfolds deep within those planets, the consequences are profound. Each drop of falling diamond would release energy as it sinks potential energy converted into heat-fueling convection currents, stirring the planet's interior. Billions of tons of crystals could rain in slow cascades, their descent generating enough warmth to explain why Neptune glows brighter than it should. And perhaps even Saturn's excess heat. That mystery of thermal surplus is driven not merely by hydrogen compression, but by this crystalline rain falling unseen within. The idea bridges the giants from Jupiter's metallic hydrogen core to Saturn's plasma mantle, to Uranus's icy ocean to Neptune's molten diamonds. All are connected by pressure alchemy matter transforming endlessly under gravity's hand. This could be why their magnetic fields behave so differently, because each planet's conductive layer is not uniform but sculpted by dynamic chemistry. A layer rich in carbon conducts differently from one rich in hydrogen. A planet that rains diamonds could also bend magnetism just as a musician bends sound. The gas giants then are not merely passive recipients of the sun's energy. They are internal engines, self-sustaining laboratories of physics, where energy is not only received but created. It is a poetic irony the coldest, farthest planets may burn most fiercely within. And if Neptune's storms, Saturn's auroras, Jupiter's lightning and Uranus's magnetism are all signatures of this internal energy, then what we are witnessing is not chaos but balance. Each world in its own way converts gravity into heat matter, into motion, silence into sound. Perhaps the diamond rain is more than a physical event. Perhaps it is the mechanism through which the universe keeps these giants alive. They shine not because they borrow light, but because they remember it. When Voyager 2 left Neptune in 1989, it turned its camera one last time. The blue planet glowed like an ember in deep space, small, perfect, unreachable. And in that image perhaps lies the quiet truth about all these worlds. They are not just orbs of gas, but expressions of the same cosmic rhythm that shaped us. Saturn spins like a golden wheel, its rings singing gravity's song. Jupiter rumbles with thunder and radiation, the guardian who both protects and disturbs. Uranus rolls sideways, haunted by the echo of an ancient collision, hiding oceans of ice and diamond. Neptune breathes storms that break the speed of sound and light that burns from within. 4 giants, 4 variations of the same experiment, each rewriting what physics means when pushed to its edge. The diamond rain hypothesis is not merely about jewels falling in darkness. It is about transformation, how the universe takes chaos and pressure and turns them into order and light. It's a mirror for us, for everything alive. Under enough pressure, even carbon becomes something radiant. Perhaps that is the quiet message these worlds are sending. That beauty is not an accident, but an outcome. That from gravity's grasp and isolation's silence, something new can always emerge. And as we listen to their distant radio hums, the static songs of Saturn's rings, Jupiter's lightning, Neptune's winds, we are in a way listening to ourselves, fragments of the same cosmic memory vibrating across time. Cassini's plunge, Voyager's departure, Juno's orbit, all of them are steps in a symphony still unfinished. One day another spacecraft will fall again into the clouds deeper than Cassini dared, and perhaps it will confirm what we already sense, that within those storms, those magnetic fields, those impossible rains, there lies not just matter, but meaning. Until then, the giants sleep and sing, not dead, not alive, but dreaming. And somewhere within their endless pressure, the universe continues its most ancient act of creation, turning darkness into light and silence into song. When Cassini's signal faded into static, it didn't vanish. It scattered into patterns, into numbers, into fragments of noise still whispering through the archives of Earth. Each byte of its transmission, once decoded, tells not a story of ending but of persistence. Scientists still sift through that digital dust. They find subtle irregularities, tiny fluctuations in radio frequency oscillations, in magnetic readings, shifts in ion density that should not exist. To some, these are merely instrumental echoes. To others, they are the language of a living system, a planetary hum that continues long after the spacecraft burned away. Across disciplines, astrophysicists, fluid dynamicists, and plasma theorists are beginning to see something familiar in the data from Saturn, Jupiter, Uranus, and Neptune. Not chaos, but patterns of self-organization. Every storm, every tilt, every magnetic twist seems to follow fractal rhythms, where order emerges from turbulence. Saturn's waveforms match harmonic ratios seen in ocean tides on Earth. Jupiter's lightning storms pulse with frequencies resembling those in the human brain. Neptune's winds fluctuate like heartbeats measured over planetary scales. Coincidence, perhaps, but perhaps not. In nature, order and chaos are not opposites. They are phases of the same conversation. The giants, then, might not simply exist as isolated phenomena. They might respond to the sun's variations, to each other's gravities, to the deep vibration of space itself. In this view, Cassini's data is no longer just information. It is memory, the record of a dialogue between planets, and physics between motion and stillness. And like all memory, it carries an aftertaste of meaning, something that refuses to stay purely mechanical. Maybe that's why the silence after Cassini's fall felt so heavy, because what it left behind wasn't absence, it was resonance. Everywhere we look in the outer solar system, we find paradoxes. Planets warmer than they should be, magnetic fields out of alignment, rings that refuse to disperse. These contradictions are not failures of physics, they are frontiers of it. Perhaps what we call anomalies are simply places where our equations haven't yet grown wide enough. Cassini, Juno, Voyager, and the future Dragonfly mission are not just explorers. They are architects of comprehension, building bridges between what is measurable and what is imaginable. When we study the giants, we confront energy itself in its purest, most untamed form. Gravity transformed into heat, pressure transformed into magnetism, motion transformed into order. From Saturn's auroras to Neptune's internal fire, every anomaly whispers the same thing. Energy never disappears, it only changes the language it speaks. That lesson ripples far beyond planetary science. The physics that governs diamond rain magnetic drift and convective storms may hold insights for fusion, energy, planetary engineering, even climate modelling on Earth. In a sense, these distant worlds are not only mirrors of creation, they are prototypes of endurance. Worlds that have thrived in extremes for billions of years without collapse, teaching us resilience not through words, but through structure. Jupiter stabilizes, Saturn harmonizes, Uranus adapts, Neptune endures. Together they form a living spectrum of cosmic equilibrium, not chaos, but complex stability, reminding us that balance can emerge even from asymmetry. Perhaps that is the lesson we are meant to learn, that survival like magnetism is not about alignment, it's about continuity. When Voyager 1 looked back for the last time and captured the pale blue dot, Earth appeared as a speck suspended in light. If it had turned a little farther, perhaps it would have glimpsed the faint blue glow of Neptune 2, a sibling light at the edge of sunlight's reach. Beyond Neptune, the Kuiper belt extends like a whisper of frozen possibility. Thousands of worlds orbit there, relics of formation waiting for another mission, another Cassini to uncover their nature. Some believe a hidden planet, Planet 9, may still drift in that darkness, massive, distant, unseen, shaping the orbits of everything else from afar. If it exists, it would be the fifth of the giants, a missing movement in the solar symphony. But even without it, the music continues. For the outer planets are not separate notes, but variations of one theme, gravity translating silence into structure. Each probe we send outward Voyager, Cassini, Juno, Dragonfly, becomes an echo of ourselves, a reflection of the same curiosity that once made humans lift their eyes to the sky and count the stars. Our machines become messengers, our data becomes poetry, our discoveries become mirrors. In their orbits, we find more than numbers, we find a question that will not die. Is the universe alive? Not in the biological sense, but in the way that it remembers, adapts, and reimagines itself across time. Maybe every storm, every ring, every field line is a neuron in some vast cosmic mind, and every transmission from Cassini or Voyager is a fleeting thought travelling between consciousness and eternity. And if that is true, then perhaps the giants are not out there at all. Perhaps they are within us, the parts of our own nature that seek rhythm in chaos, that dream of balance amid pressure, that create light when the world grows dark. The story of Saturn and its kin was never about distance. It was about reflection, how the farther we go, the more clearly we see what we already are. So as the last data streams fade and the next missions awaken, the question remains suspended in the cosmic air. If planets can sing through gravity and diamonds can fall like rain, what might we be capable of when we finally learn to listen? Every system breathes even one made of stars and stone. From the smallest atom to the largest spiral galaxy, there exists rhythm, oscillation, pause, return. In that rhythm, our solar system too seems to inhale and exhale, though its lungs are made not of air but of gravitational resonance. Between the orbits of Jupiter and Saturn, patterns emerge every few centuries, slow, gravitational tides that subtly reshape the paths of planets, comets, and even Earth's own climate. Astronomers call it the Great Conjunction Cycle. Every 20 years, the two giants align, sending waves through the heliosphere, small but cumulative like a universal heartbeat. And if we listen carefully, Uranus and Neptune join that rhythm too, weaving longer beats the deep pulses that modulate the solar system's long-term evolution. Some researchers have even found correlations between these conjunctions and solar activity, as if the outer giants whisper to the sun, and the sun answers with flares and cycles of light. It's tempting to think of coincidence, but perhaps on cosmic scales, coincidence is communication. If Saturn's rings can record vibrations within, if Jupiter's storms can generate electromagnetic music, and if Neptune's magnetism can pulse irregularly through its carbon sea, then the system itself is speaking in a dialect of gravity. Cassini's plunge, Juno's orbit, Voyager's drift. They have not only captured data, they've tapped into this rhythm. Each measurement, each magnetic wave, each acoustic echo is a breath of that larger living architecture, the pulse of a system that has never truly been silent. When we think of the giants, we think of mass titanic spheres of gas weight and pressure. But their truest role may not be mass, but exchange. In a solar system that thrives on balance, the outer planets act as reservoirs, regulators, and catalysts. They store, redirect, and release energy in forms our instruments only now begin to decipher. Consider this. Saturn radiates twice the heat it receives. Neptune burns with internal fire. Jupiter hurls radiation like a miniature sun. Uranus, quiet and cold, may serve as a stabilizer, a counterbalance against excess. Together they form a dynamic circuit, transferring momentum and energy through magnetic fields and gravitational tides. Some astrophysicists have begun to propose a daring concept that the outer solar system acts as a closed energetic feedback loop, where internal heat and orbital resonance maintain systemic equilibrium. Each storm, each pulse, each field reversal is not random chaos, it is self-regulation. Like biological systems, these planets breathe in cycles of entropy and order, and perhaps that is what Cassini and Voyager truly recorded, not just environments, but memory. The way these worlds preserve information in motion, the trace of ancient collisions, the memory of heat, the echo of magnetic alignment. Matter, after all, is a slow form of memory. Every molecule of methane, every grain of ring dust, every shard of carbon that fell, as diamond rain carries a story, what it endured, what it resisted, and what it became. In that sense, Saturn's rings are its thoughts, Jupiter's storms are its emotions, Neptune's winds are its sighs. The giants may not think, but they remember through movement, through rhythm, through pressure. We've sent our machines into their skies and our curiosity into their cores. But every discovery we've made about the giants ultimately points inward toward us. We too are made of hydrogen, carbon, and trace metals, fragments once part of those same primordial clouds. We too oscillate between balance and turbulence, between cold silence and radiant heat. And like those planets, we hold contradictions that cannot be simplified: warmth, born of pressure, beauty born of asymmetry. Perhaps that is why the sight of Saturn's rings or Neptune's storms feels more than scientific, it feels familiar, because somewhere in their chaos we see the blueprint of our own endurance. If diamond rain can fall in darkness, if storms can circle for centuries without fading, then perhaps resilience is not a human invention, it is a universal law. The cosmos itself seems to favour persistence over perfection. As Cassini's final data streams fade and Voyager drifts beyond the heliopause, humanity faces a truth both humbling and profound. The giants are still moving, still resonating, still shaping the music of space. We are simply the latest instruments to hear it. And maybe in the end, understanding them is not about knowledge, it's about empathy. To recognise that even across billions of kilometres, we share the same pattern: energy seeking form, chaos seeking harmony, existence seeking meaning. So when we gaze at Saturn's curve or Neptune's pale light, what we are really seeing is a reflection not of gods or myths, but of ourselves scattered across the fabric of gravity and time. The universe, it seems, is not distant. It is intimate. It does not speak in words. It breathes, and through its giants, it remembers to dream. Science at its purest was never about answers. It was about echoes, vibrations of curiosity that travel through time. From Galileo's first glance at Saturn's rings to Cassini's final dive from Voyager's whisper beyond the heliopause to Juno's orbiting hum, humanity has done one thing consistently: listen. What have we heard? Not noise, but structure. Not randomness, but rhythm. Across every chapter of our exploration, we found worlds that refuse to behave, refuse to simplify Saturn, whose magnetism bends logic. Jupiter, whose storms outlive civilizations. Uranus, whose sideways spin tells a story of ancient violence and resilience. Neptune, whose heat glows in defiance of distance. Each one a deviation, yet together a harmony. The data they gave us was not merely technical, it was emotional. It taught us that order and anomaly are siblings, not enemies. That a universe filled with contradiction is not broken, it is alive. And as we learned to read that language in gravity waves, in auroral flickers, in diamond rains falling unseen, we began to understand something deeper. Knowledge does not end where certainty begins. It ends where curiosity stops. Cassini's silence was not the close of a story. It was a handover from machine to mind, from instrument to imagination. The mission ended, but the music continued. Because what Cassini truly sent us was not data. It was permission to keep asking questions that do not have to be answered. We are all of us fragments of that same cosmos part, hydrogen part, doubt part, wonder. And perhaps the act of exploring the giants was never about finding the edge of knowledge, but about discovering the shape of our own persistence. In that persistence there is something almost sacred, a reminder that to know is to care, to study is to remember, and to imagine is to belong. Somewhere beyond Neptune, Voyager still travels its signal weaker now, its batteries fading, but its direction unchanged. It carries not just instruments, but our fingerprint, a gold record etched with the sounds of wind-rain laughter and the heartbeat of a species still learning how to listen. That tiny craft, a thread of light among the stars, embodies everything we have become through our encounters with the giants. It moves forward not because it must, but because it can. That simple persistence is our definition of life. Perhaps that is what the universe has been showing us all along, that survival is not about strength, but about rhythm. That creation is not a moment, but emotion. That even silence, when heard deeply enough, contains the music of continuation. The planets we studied with their tilted spins, misplaced magnetospheres, and storms that never die are not mistakes in nature's design. They are reminders that stability is not perfection, and imperfection is not failure. Every gravitational pull, every oscillating storm, every fragment of heat, escaping Neptune's depths, is a message written in matter, the cosmos telling us how it breathes. And by tracing those breaths, we've come to recognize our own, the rise and fall of understanding, the inhale of discovery, the exhale of awe. When we gaze back upon everything learned from Cassini's sacrifice to the shimmering paradox of diamond rain, what remains is not the detail but the connection. Each question was a bridge, each observation a pulse. Together they form not a map but a mirror, a reflection of our longing to make sense of something vast and beautiful. We began by asking how the giants move. We end by realizing why we needed to ask. Because the search itself is the story. The data, the theories, the silence, all of it leads us to the same truth that the universe is not separate from us. It is the breath that moves through us when we look up and whisper, "I wonder." And in that whisper, quiet, infinite, human, the cosmos listens back. There comes a moment in every mission when the instruments fall silent, but silence is not the end. Cassini Voyager, Juno Pioneer, each fell quiet, but their echoes still travel not only across the void, but across time. Every byte of data they sent, every flicker of magnetic distortion, every radio pulse, every curve of light has already outlived its creators. When those signals first left their antennas, they were nothing more than waves of energy. But as they reached us, they transformed into memory. And memory once born does not vanish. It migrates from silicon to neuron, from archive to imagination, from the eyes of a scientist to the dream of a child who stares at the night sky, wondering if the rings of Saturn are still shimmering in the same way. This is how knowledge evolves, not linearly but organically. Each generation receives fragments, not answers, but questions, and builds something new from the silence left behind. The giants we studied, those vast laboratories of hydrogen and gravity, have become teachers not only of physics, but of humility. They remind us that our reach will always be finite, but our curiosity does not need to be. They remind us that to seek meaning in chaos is not arrogance, it is continuity. When we send machines into their clouds, we are not conquering the unknown. We are conversing with it one signal, one orbit, one plunge at a time. In the long span of cosmic history, these missions are mere heartbeats. But their meaning lies not in how long they last, but in how deeply they resonate. The data they brought back will continue to ripple through the mathematics of tomorrow, through theories yet unimagined, through the quiet hum of minds that have not yet been born. And perhaps that is the real legacy of the giants, not the storms or the magnetospheres, but the act of connection itself, a bridge of light between what was once impossible and what will someday be understood. Imagine the solar system from far beyond a faint spiral of light suspended in the dark sea of interstellar space. From there, the sun is no longer dominant. It is a single voice among billions. The planets become tiny ripples in its melody, their orbits turning like notes on an ancient record. Somewhere in that pattern, Saturn's rings flash once every few seconds. Jupiter's storms flicker like slow lightning. Neptune's reflection glows and fades as it circles the sun. To us, these are worlds of gas and physics, but to the universe they may simply be expressions of time, vast slow thoughts unfolding over eons. What if the cosmos is not indifferent but reflective? What if through observation we have become its way of knowing itself? When Cassini fell into Saturn, when Voyager crossed the heliopause, when Juno recorded Jupiter's magnetic heart, the universe was watching through us. Because our eyes are not separate from it. They are made of it. Carbon from long-dead stars, iron from collapsed cores, hydrogen from the same ancient cloud that gave birth to Jupiter and the Sun alike. Through us, the cosmos learns to see. Through our questions, it learns to wonder. And through our instruments, it learns to listen to its own heartbeat. It is easy to think that exploration ends when missions do. But perhaps exploration is not something we do to the universe. It is something the universe does through us. In that sense, every spacecraft, every telescope, every idea is an extension of its will to evolve a continuation of the pattern that began when the first atoms formed, when the first stars lit, when the first consciousness opened its eyes. There will come a day when even the memory of Cassini and Voyager will fade when their signals have long dissolved into cosmic background. But the curiosity that built them, that eternal impulse to ask, to imagine, to reach, will remain encoded in the next form the universe chooses for itself. Perhaps not human, perhaps not even biological, but alive in thought, in pattern, in resonance. For now, as we drift through this brief moment of awareness, the giants still turn, still shine, still breathe. They are not gods, nor machines, nor mysteries to be solved. They are the universe remembering itself in slow motion. And we, the listeners, the dreamers, the storytellers, are simply the echo returning home. In the end, everything returns to stillness. The data, the storms, the light all fold back into silence the way waves return to the sea. Not as loss, but as completion. The story of the giants is not about where they are, but what they've done to us. They changed the scale by which we measure wonder. They reminded us that truth is not always sharp and definite. Sometimes it is soft, slow, and luminous. Cassini's final descent, Voyager's fading heartbeat, the diamond rains of distant worlds, none of these are separate moments. They are chapters in the same sentence written across the language of gravity. Now, as our machines drift beyond the reach of the sun, they carry not just data but intent, the quiet message that curiosity itself is an act of creation. Each orbit, each signal, each question was never truly about understanding them. It was about awakening us. Perhaps that is the final secret of the cosmos, that the universe does not end in darkness, but in reflection, in the gaze that looks back and realizes it has always been part of what it sought to see. When we close our eyes now, the rings of Saturn still turn, the storms of Jupiter still roar, the diamonds of Neptune still fall unseen, uncounted, and somewhere far beyond the reach of sunlight, Voyager still moves a small echo of our breath, still carrying our questions toward whatever comes next. Not everything that fades is gone. Some things like wonder remain suspended between knowing and dreaming, and maybe as the universe keeps expanding, that's what we are meant to do as well, not to reach an end, but to keep unfolding quietly, endlessly, in the rhythm of discovery and the calm after it. Because in the vast silence between the stars, under all the equations and all the questions, there is only one enduring truth left to whisper. We were here. We listened, and the universe softly, patiently listened back. The night has grown quiet now. The storms have slowed, the signals have faded, and the echoes of every orbit drift softly into the dark. Yet even here in this final hush, nothing truly ends it, only changes its form. The planets still move, tracing their endless circles like thoughts that never tire. Their gravity hums through the void, a lullaby of motion patient and eternal. We have followed that hum across light years of silence, only to find that the rhythm we chased was never foreign. It has always been the same rhythm that beats behind our ribs. Knowledge brought us closer to the stars, but wonder made us stay. Because when the instruments fall quiet, what remains is not data but devotion, the human need to reach out into the dark and whisper, what else is there? Perhaps the universe will never answer in words. It speaks instead in light, in the shimmer of rings, in the quiet fire within Neptune's blue heart. And in those signs, faint yet enduring, we are reminded that comprehension is not the end of curiosity, it is its continuation in gentler tones. So we leave this story not as explorers but as witnesses. We have seen worlds that defy rules, rains that fall as diamonds, and storms that last beyond centuries. We have learned that chaos can be elegant, that imperfection can endure, and that even in the coldest distances something still glows. Now the stars exhale, the giants drift into dream, the universe closes its eyes just for a while and waits for the next signal, the next gaze, the next question. Until then, the cosmos sleeps not in darkness but in quiet light, and somewhere in that light we are still listening,